Hello everyone. Let's start with a simple question. Why does a balloon expand to fill the entire container while water just sits at the bottom? That's because gases behave very differently from solids and liquids. Solids are rigid with definite shape and volume, liquids flow with definite volume but no fixed shape, and gases, the rebels, have neither. They spread endlessly to occupy whatever space they are in. This strange behavior makes gases unique and worth a closer study. Now let's focus on what makes gases so distinctive. Their molecules are like kids in a huge playground, far apart, running wildly in all directions. Because of this spacing, gases can be compressed easily and they exert pressure equally in all directions. They don't need an invitation, they expand automatically to fill the container. The force of attraction among molecules is almost negligible, and that's why gases mix quickly and uniformly. That's why perfume spreads across a room in seconds thanks to diffusion. Imagine three worlds: solids are strict soldiers, standing tightly packed with strong forces. Liquids are dancers, close but with some freedom to move. And gases? They're like wild partygoers, spaced far apart, bumping into each other and the walls randomly. These collisions are elastic, meaning energy isn't lost. That's why gases can exert continuous pressure even though each molecule is tiny. Greater spacing also explains why gases are far more compressible compared to solids and liquids. Here's the science behind it. Gas molecules are in constant random motion, colliding with the container walls, and that's what creates pressure. The average kinetic energy of these molecules is directly proportional to the absolute temperature. In other words, hotter gas equals faster molecules. That's why a football left in the sun seems more inflated, it's just molecules hitting the walls harder and more often. Pressure, volume, and temperature are interlinked, and this is the foundation for gas laws like Boyle's and Charles'. Let's test this with a real life example. Take a balloon filled with air and put it in the freezer. As the temperature drops, the molecules lose kinetic energy and move slower. They collide with the balloon walls less often and with less force. Internal pressure falls and the balloon shrinks. It hasn't lost air, it's just the molecular speed slowing down. This shrinking is nothing but a daily life demonstration of Charles's law waiting to be formally studied. Gas properties aren't just classroom fun, they drive our world. Compressed oxygen cylinders are lifelines in hospitals. Hot air balloons rise because heated air becomes less dense than the cool air outside. Perfumes diffuse through the air in seconds. Refrigerators keep food fresh by using gases that expand and compress. Even weather patterns and the very act of breathing depend on gas laws. So, whenever you open a soda bottle, fly in a balloon, or smell popcorn from afar, remember, it's gas behavior in action. To sum up, gases differ from solids and liquids because their molecules are far apart and weakly attracted. They are highly compressible, expand freely, and move randomly. This motion explains diffusion, pressure, and the effects of temperature. Understanding gases gives us the foundation for studying the beautiful symmetry of gas laws, Boyle's law, Charles' law, and the general gas equation. So next time you breathe in deeply, remember, you're literally living in a world ruled by gas laws.